We're recording to the cloud. All right. How's it going, everybody? No, I haven't graded your exams yet. That was 2 days ago, and I gave 3 exams. I gave 2 exams on Wednesday, and I gave 1 yesterday. My game plan is to grade them all and get them kind of back to you by Tuesday at the very latest, so I can get them back to you within a week of turning them in. So I will get those done for you, and because you took yours first, I will kind of make you top priority in grading. Hopefully this previous exam felt a little bit better than the first one now that you know what to expect. And I tried to keep an eye on the questions and make sure that they weren't too difficult. So hopefully that'll go well. So I've got a couple of quick announcements for you. First of all, we do have a quiz that we'll post today. But considering that we are just starting a brand new chapter today, I did actually make the deadline Wednesday at 5 so that you have a little bit more time to start moving through chapter 8 and reading chapter 8. And I think you're going to like today's class because we're going to do a lot of puzzles. So get a piece of scrap paper out because we're going to talk a lot about like problem solving and stuff today. So be prepared. Okay, so let me go ahead and share the screen. I'm gonna pull up notes for you. Did everybody who's first year enjoy Women Who Wow?
It was kind of hard to understand them. They didn't have caption.
Oh, I'm so sorry.
Well, my after the US teacher said this one. No, it's one of my friends could hear it a little bit better, so they put that.
It picked you up on the caption. You are very good at projecting. Okay, so we are moving on to chapter 8. This is the last thing that we will really talk about with cognitive psychology. We are going to talk about thinking. We're going to talk about language, and we're going to talk about intelligence. Now, remember that because this is an introductory class, this is going to be very cursory. It's going to be more of a survey of these different topics. If you're interested in learning more about things like judgment and decision-making and problem solving, I do cover those a bit more in cognitive psychology, and I offer that every fall. All right, so when I talk about thinking, I'm talking about cognition. Now, cognition is a word, and I get that I am kind of being a little bit recursive here. Cognition is basically any mental activity that is associated with thinking, knowing, remembering, paying attention to things, and communicating. So some of the different, we've already spent a pretty good section on memory and remembering. But for this chapter, we're largely going to talk about some of the other mental activities that fall under the header of cognition, and that includes problem solving, decision making, and judgment formation. And interestingly enough, if you had to estimate how many decisions you make a day, how many do you think you actually make? So many, okay. So many isn't a number. So many isn't a number. If you had to put a number on so many, what do you think it would be? 100,000? Okay, that's a little on the higher end. It turns out we make, ballparking it, 35,000 decisions every day. So things like what you're going to wear, what time you're going to wake up, what you're going to eat for breakfast, how much you choose to eat. Now, you may not think of those as decisions, but they absolutely are. And so one of the things that a lot of researchers have been talking about lately is the fact that you probably have a significantly larger number of choices than probably your parents or even your grandparents had. We have a lot more options. We have a lot more things vying for our attention. And so we have to make more choices than our ancestors did. One of the things that we know is that even if you don't think that the choices that you are making, even though you don't really think they use up a lot of your energy, one choice, probably not a lot, but if you're making 35,000 a day, that's a lot of little bits of cognition and energy that you are using every day. So there is actually something referred to as decision fatigue or choice fatigue. So be aware that sometimes if you want to cut down on choice fatigue, sometimes making your choices a little bit easier often helps. I pretty much almost have the exact same breakfast every day. I kind of get into a rut, and this can kind of cut down on the fatigue that you might experience when you make these kinds of choices daily. That can free up your energy for making decisions that really matter.
I just had to make 55 choices in my biology class.
Yikes, that's a lot. Okay, so first we are going to talk about problem solving. So in everyday life, you are going to run into problems. I actually had a problem that I had to basically try to figure out and solve for probably the better part of the week. Trying to figure out how to make sure that students next semester get a required course when nobody is available to teach it. And we ended up finding a solution because, well, I talked to somebody who is much, much smarter than me, and they threw out the idea to teach it in the summer. And once that happened, it was like, oh, it's the perfect solution, even though nobody likes taking summer classes, but, you know, I might have a kitten by then. So they would get to see the kitten before anybody else. So there are perks. But oftentimes when we try to solve problems, this can include things like your tire got a flat and you don't know how to change a flat. So how are you going to get help and make sure that you can go somewhere to actually get your car repaired? Your problem solving could be you have a meeting at noon, but you also have class at 1. So how are you going to try to find time to get lunch and attend your meeting and make it to class without running late? So we have a variety of different problems that we might encounter every day. And we have different types of strategies that we can use to solve these problems. So the first one, I'm going to talk about the other 3 in depth on the next slides. But the first one is trial and error. This is basically when you try to, I like to call this the spaghetti method, because you basically try to throw spaghetti at the wall in random ways to see if it'll help you find a solution. And you basically try to take what sticks. So you're basically trying to find random solutions. You're not trying to do it in a systematic way. You're just trying to solve the problem. So does anybody here watch The Simpsons? Okay, yeah, probably not. I know. It's been out since 1987, so, you know. But there's a really good episode that I like where Homer has a kid's placemat with a maze on it. And the idea is that you have to go through the maze and avoid the alligator. And so he starts picking random paths to follow. So he's not actually doing this with any sort of insight or knowledge. He's not making his decisions based on what he did before. And he ends up right in the alligator's mouth again. And he crumbles up his maze and throws it on the ground. The waitress comes next to him and you look and there's just tons of crumpled up placemats on the floor because he keeps trying trial and error to get out of the maze. The waitress comes up to him and goes, "Another placemat?" And he goes, "Please." And it's just a cute little moment that really shows trial and error. There's no insight. You're just trying random stuff, which means you're going to make a lot of mistakes. Homer doesn't appear to learn from his mistakes, but you can.
I have never seen that episode.
It's a very old episode. I forget the name of it, but it's like season 3 or season 4. It's pretty old, but I love it. Okay, but trial and error just really, as a problem solving method, it's generally not advised because you're basically trying to find a solution in a random way. The other 3 methods that we're going to talk about tend to be a bit more useful. So when we talk about an algorithm is basically when you try to work through all possibilities before you reach a solution. So what you're looking at here is kind of a word scramble. The technical term is that it's an anagram. So we can unscramble these letters to find a word. So what we're going to do, an algorithm will look at all possible iterations, so all possible combinations of these different letters. So algorithms can be really useful. They will get you to the solution. Computers often solve problems and find solutions by doing algorithms. So if you're ever interested in a class in computer science, or if you want to get a degree in computer science, you actually have to take a class all about algorithms. And algorithms work, but because you are looking at every possible solution, they also take a lot of time. So here we have a word scramble. And you can kind of see there are a lot of letters. And because there are a lot of letters, there are a lot of different combinations here. Now, the algorithm will eventually get us to the solution, but you have 907,200 possibilities that you have to search through before you can confidently say, I know the answer. It'll get you to the solution. It's effective, but it's long. Bronwyn, you look a little confused.
Oh, I mean, psychology.
You ruined it. You spoiled it. Did anybody not know it? Well, now you do. Oh, no, it's okay. I don't actually care. It's in your textbook too. So if you're keeping up with the reading, this shouldn't be that hard to figure out. And I'm not actually spoiling anything. I'm teasing you.
Okay.
I'm teasing you. This is something I don't mind you spoiling. Now, some of the other puzzles that we're going to do later, if you know the solution, don't spoil it. It's part of the fun. Okay, so obviously, an algorithm will get you to the solution, but it takes a lot of time. So one of the other things that we often do to try to make problem solving easier is what is known as a heuristic. Now, when I talk about heuristics, I'm going to wiggle my thumbs, and hopefully this will help you remember that a heuristic is basically nothing more than a little rule of thumb. So these are very simple thinking strategies. Heuristics often come from our prior experiences with solving problems. So heuristics are basically these quick and dirty strategies that we use to solve problems. They are less time consuming, but occasionally you will make mistakes. They are a bit more error prone. So here's an example. We can actually use heuristics to help us solve this problem. You have a pretty good knowledge of the English language. So you automatically know that very few words in the English language start with Y. Very few words in the English language also start with YY. So because of that, you can already say, well, it probably isn't something that starts with YY. Additionally, you and I both know that many words in the English language end in Y. So we can put a Y at the end. This is a pretty simple thinking strategy, and see if we can scramble the word around and see if it begins to make a little more sense. So something like this, and then something like this, ta-da! You probably already knew the answer, but there it is in case you didn't. Oh gosh. So remember how I said that you make 35,000 different decisions daily? It's been estimated that you make over 200 different decisions a day related to food. Again, how much, what you eat, when to start, when to stop, all those different things. Yes.
Never mind. So
Oh.
you mentioned food, and I started thinking about food. And I know what one of the soups is today, and I was gonna ask a stupid question.
Oh, okay. Well, today is apparently also the popped up baked potato bar. I actually went to the dining hall yesterday because yesterday was meatless chili day, and I love the meatless chili. Like meatless chili. Ah, it's so good. It tastes like real chili. That's why I love it.
I usually unmeatless the meatless chili, like on the sandwich bar, I'm putting like chicken chunks.
That's okay.
It's good.
That's okay. Just don't put chicken chunks in anybody else's chili.
No. I get my own.
You're like that. Like I've occasionally heard of pranks where people like put meat in people's food that don't eat meat. Don't do that. That's rude.
Some people are also like allergic. to
Yes,
meat.
that's the other thing. I've also heard similar ones where people are like, I like when somebody comes up and asks for Diet Coke and I think they're too thin, I give them regular Coke. Somebody might be diabetic. Don't do that. Okay. So here's another common heuristic. So let's kind of talk about some of the errors that we can occasionally make. And we'll get there in a minute, but here's another common heuristic. So let's say I want you to list all the words in the English language that start with the letter Q. So here, oftentimes we know that most words that start with Q are followed by a U. Now that's obviously not always the case. But most of the time we do find that Q often is followed by U. Additionally, because we have Q and U, we're going to assume that the next letter probably has to be a vowel because Q and U together makes a qua sound. It said Quora. That's funny. It's a qua sound. So we're going to assume that the next letter probably has to be a vowel. Now, this is going to help us out a lot, but there might be some ones that we miss as a result. Everybody good? Okay, so another way that we can actually solve problems is through what is known as insight. So how many of you have had an instance where you're trying to solve a problem, you've spent a lot of time kind of racking your brain about it, and then you decide to go and do something else? So oftentimes I find that this happens with me when I'm coming up with research ideas. So I want to try a new research study. Somebody's given me some good feedback for how I should plan it, but I have no idea how to implement it. So I sit there and I read different papers and I rack my brain and I still can't come up with the solution. And then I go do something else. And usually with me, This apparently tends to happen when I'm in the shower. So I'll be taking a shower and I'll be washing my hair, and all of a sudden, boom, the correct answer suddenly pops into my head. I have an idea for how to solve the problem, and this is what is called insight. This is basically the sort of feeling that I got the other day when the person who is much, much smarter than me basically gave me the solution to my research methods problem. I went, oh, that's it. Aha. So you get this kind of aha experience where the solution suddenly pops into your head. Now, here's what's really interesting about insight. Insight is a genuine different state of problem solving compared to standard problem solving. So here's what I mean. So this is time on our x-axis. This is reaching solution. I'm not going to write all the way up to reaching solution. I'm running out of space. Now, when you solve a standard problem, like a math problem, like the kind you get in calculus that are always about flying kites, and the string is getting longer and you have to calculate the rate of change of the kite string. It's always shadows, kite strings, or if you're doing integration, it's always a sand pile that's getting bigger and bigger. All the calculus problems are like that. But if you're going through a math problem over time, you are going to get progressively closer and closer to the solution until you reach it. Insight, people have actually looked at this. So this is what is called a feeling of warmth. So how many of you have had an instance where you hid a present for a friend and you're trying to get them to find it? And they walk around and you go, oh, you're getting warmer. You're getting warmer. They walk away from it. Oh, you're getting colder. So they've actually had people rate their personal feelings of warmth as they work through a problem. With standard problem solving like this, the feeling of warmth towards the solution gradually increases until the solution is reached. With insight, it's different. The feeling of reaching the solution and the feeling of warmth looks like this. I don't know it, I don't know it, I don't know it, boom, I know it. They've actually rated these they've actually noticed these differences that people report when they do standard problem solving versus insight. And the time between not knowing the solution and suddenly getting the solution is about 0.3 seconds. So remember the Gestaltists? Okay, you're like, we'd like to forget the Gestaltists. Well, unfortunately, you can't, because they actually did a lot of work with problem solving, and they did a lot of work with chimps. So what they would do is they would put chimps in these situations where they would have to try to problem solve, and you can kind of see they got a banana up there on a string. And so they put the chimp in this room with a bunch of different boxes of varying heights. And it's only through accident that the chimp basically learns that you can stack the boxes and get the banana that way. So they've actually looked at problem solving and insight, and it turns out that chimps actually do insight problems the same way that we do. Okay, do not write this down. So how many of you love a good punchline of a joke? Getting the solution of a joke, part of the reason that it's so fun to get the joke is because getting the solution and recognizing the humor is actually a form of insight. So I think this was a previous edition of your psychology textbook, but what we basically find is that insight is often contributing to our humor experience. So your textbook, one of the previous editions rated this as one of the funniest jokes of all time. It's debatable. Like anytime somebody's like, that's the funniest joke of all time, I'm like, humor's subjective. I like dad jokes. Nobody likes dad jokes but me. And they're definitely not always funny. Okay. But here's the joke. You don't need to write this down. A couple of New Jersey hunters are out in the woods when one of them falls to the ground. He doesn't seem to be breathing. His eyes are rolled back in his head. The other guy whips out his cell phone and calls the emergency services. He gasps to the operator, "My friend is dead. What can I do?" The operator, in a calm, soothing voice, says, "Just take it easy. I can help. First, let's make sure he's dead." There's a silence. Then a shot is heard. The guy's voice comes back on the line. "Okay, now what?" That's dark, but you get it. And all of a sudden, the make sure he's dead and seeing what happened next, you're like, oh, I get it now. Now, there are a couple of different obstacles when it comes to solving problems. So, for example, one of the big problems that we often tend to find is confirmation bias. Basically, cherry picking information that fits with your idea and confirms your preconceptions, and basically ignoring anything that doesn't fit. So you have a tendency to only search for information that confirms your preconceptions. So in general, you should be looking at a variety of different sources if you want to understand something or solve a problem. And that means occasionally looking at information that comes to a different point of view than you. And I'm not always saying I've got it down, but I think we're in a very interesting time where people equate doing research with looking at things on the internet that fit with their point of view, oftentimes not looking at peer-reviewed verified studies. Yes.
There was a person asking online about like peer-reviewed studies that were anti-vax because they were writing a paper in college.
Oh, I've heard about this. It's a very famous Reddit thread.
Yeah, and they're like, does she seriously not get why there's no peer-reviewed research? Because I mean,
the only one that you could potentially make a claim for is Andrew Wakefield's famous paper from 1998 that basically equated vaccination with causing autism. That first, and I will mention, that paper has been retracted, so you shouldn't listen to it. Additionally, the way that Wakefield gathered his data was by and large fraudulent. Like maybe you can make that like, now, whether or not you choose to vaccinate is up to you, but the research is pretty clear. And yeah, peer review, by the way, has some issues. I'm a peer reviewer. I review articles sometimes. I don't get paid for my work. It is a thankless job, but it helps other people with their research and it helps you stay current in the field. Peer review has a lot of problems, but I'm going to probably trust the opinions of experts who know what they're talking about. I generally only get papers that are related to my area of expertise. So I get papers on cognition in older adults, cognition in kids, and usually there's something related to memory or attention of some kind. I don't get papers on vaccines or things like that because that is not my area of study. And in general, I tend to find that if there's something I don't know a lot about, I want to defer to experts and I actually want to look at what the data say, even if I don't agree with the data. Like the data is pretty clear. Now, another problem that we have with problem solving is fixation. This is an inability to see a problem from a new perspective. It's almost like we get stuck in this fixed mindset that this is the only way that we can solve the problem. And because we have such a limited mindset, we can't solve the problem because we can't get out of our mindset that we're stuck in. So we're going to try something. Oh, I know. I'm sorry. I got too excited. I was like, ooh. We get our first opportunity to do a puzzle. I'm so excited. All right. Okay. So here's what I'd like you to do. take a few minutes. We're going to take maybe about 2 or 3 minutes to try to solve this problem. How would you arrange 6 matchsticks to form 4 equilateral triangles? So let's talk about a couple of things. So equilateral means that all the sides have to be the same length. Here's a couple of other things. You cannot break the matchsticks. Don't even try. So go ahead and try to see if you can write out your solution. And I'll probably ask you in about 2 minutes if you're still stuck. And I'm going to go look around. So if you are watching this on video, I am not leaving you. I'm just going to go look at possible solutions. If you are watching this on video later, you can also try this yourself. Okay, I'm going to go take a look really quick. It's kind of fun to draw it on your tablet, isn't it? You're like, kind of. Okay, is that flat? Oh, okay. So one thing that I will mention, because oftentimes, okay, look. Was that for a different class? That could have been really useful on Wednesday. Okay, so I will tell you this, because when I first got this problem in cognitive psychology, this was my solution. And I'm going to tell you why it doesn't work. So some of you are doing this where you got 1, 2, 3, 4. Okay, so far so good. Here's the problem. All the matchsticks are the same length. So you're not actually forming a triangle when you do this because they're not touching. So is anybody having some problems here? So here's a hint. I never said that this had to be flat. Maybe we have some, I never said the matchsticks had to lay flat. Maybe some of you have flashes of insight right now. Yeah, there it is. Oh. All right. Did anybody get something that looks like this once I said it didn't have to be lay flat? So that's fixation, right? So you're assuming because the matchsticks are laying flat that your solution must also lay flat. You are stuck in a perspective that I never actually gave you. You're the one who was stuck there. And so once you're kind of freed from that fixation, it gives you an opportunity to try new creative solutions. Okay, so that's our solution. We're going to have another puzzle in a minute, so get ready. Huh? Okay, let me take a look. Can you hold it up for me? Okay, so that maybe the one thing I would want to check with that is that they're all the same length, and they may not necessarily be, but that's one possibility. But that would actually give you more than 4. because technically there are triangles embedded in those triangles. We want exactly 4. You actually have like almost 6.
Yeah.
So you have more than 4, but that is a clever solution. All right, so something that's kind of related to fixation is what is called functional fixedness. So whereas fixation is centered upon a way to solve a problem and being stuck in the idea that the problem can only be solved one way, functional fixedness is basically your tendency to see the function of an object as fixed and unchanging. So it's a subset of fixation. It is specifically related to objects and what their apparent functions are. Okay, so I'll wait for a few of you to write, and then we're going to do another problem. Okay, so this is a pretty famous problem that was originally developed by Carl Duncker. This is called the candle mounting problem. So using the materials that are right here in front of you, how would you mount a candle on a bulletin board? So here's what's really critical. You have to set this up in such a way that wax doesn't drip on the floor. So go ahead and take another minute to try to draw out your solution to the problem. And I know that I'll get this because this came up in my cognitive class. No, the thumbtacks are not long enough for you to nail the candle into the wall. So don't even try. Okay, let's go ahead and take another look at what other solutions people came up with. Okay, don't light the candle. Well, that's one way to make sure that wax doesn't drip on the floor, but you gotta light it. It's okay. Okay, I've already seen 3 people get it. So I think me talking about functional fixedness here actually helped. So did I say that that matchbox only had to be for holding matches? How many of you got this? Cool. Nice job. So part of the reason that we get kind of stuck with this problem is that when you look at the original picture, look, it's holding all the matches. So you get this idea that the matchbox can only be for holding matches. and that it can't be used for anything else. So once again, we need to think about the idea that objects that we use every day probably have more uses than we give them credit for. Bricks can be used for houses. They can also be used as a doorstop. And in a couple of cases, the students in my cognitive class have said they can potentially also be weapons, but I don't like violence.
What's red and bad for your teeth?
Is it a brick?
Yeah.
Oh my gosh, that's awful. That is terrible. Oh my gosh. Okay, so let's move on to talking about making decisions and forming judgments with the 10 minutes we have left. And folks, I am so glad you are here. In case I haven't said this, I'm always really grateful to have you in class, and I'm happy to have you here. So every day we make hundreds and thousands of decisions solely based on our gut. We very rarely use systematic reasoning. This morning, I had apple Pop-Tarts for breakfast, and I didn't really think very much about making them or what I was going to make. I said, I don't have a lot of time this morning. I'm going to make Pop-Tarts. I haven't had Pop-Tarts all week. I've been eating mini wheats with almond milk, so I want Pop-Tarts today. And oftentimes we don't necessarily very carefully think through our decisions, and that's okay. As I kind of mentioned last week, generally the fate of the universe does not hinge on what you wear today or what you have for breakfast or a lot of other decisions that you make. But sometimes the decisions that we make, even if they don't use systematic reasoning, can have big consequences. You answering a text while making the choice to answer a text while you're driving your car can have incredibly negative consequences. All right. So I want to talk a little bit about, oh, did you need me to go back?
Yeah.
Oh, I'm sorry. I saw your face. I'm like, she wants me to go back.
I'm almost there.
Oh, no, it's okay. You know how I get when I get excited. I'm like, let's go on to the next one. Let's go. I'm just so excited to teach you things.
I didn't realize the candle was supposed to stay intact, so I was like, just melt the candle.
No, you can't melt the candle. You can't.
Actually,
It's
No,
not
it's
gonna,
the wax.
it's not going to stay on the wall if you melt the wax. Because
Well,
sometimes I get that too.
I still put it in the box. It
Okay.
just melted in the box.
Well, you can stick a thumbtack in the bottom, like the paper of the box is thin enough that a thumbtack through the candle at the bottom will hold. You good now? Okay. So you are looking at two researchers, the late Amos Tversky and Daniel Kahneman. So one thing that I will mention, there is no Nobel Prize in psychology. Psychology was not an established discipline when the Nobel Prizes were basically formed. However, we do actually have a few psychologists who have earned the Nobel Prize, but typically they earn the Nobel Prize in economics. So Amos Tversky and Daniel Kahneman have actually earned the Nobel Prize in economics for their work on heuristics. When we are making judgments and making decisions, I mentioned that heuristics are very quick problem-solving strategies, but that they're prone to errors. And so we're going to talk about two different heuristics that we often use to judge things. And we're going to talk about the representativeness heuristic, and we're going to talk about the availability heuristic. Now, Daniel Kahneman has written a book called Thinking Fast and Slow. Normally, I would recommend it to you. We do have a copy in the library. However, he cites a lot of studies in his book that don't replicate. And so I generally cannot recommend that to you, and it's kind of long. But if you're interested and you want to learn more, check it out. Now you can probably expect, and I will say this, I have not written your next test because even I don't write the next test the day after I've given one, but I think you should probably know I will probably be asking something about the representativeness heuristic and the availability heuristic. So today and on Monday, take good notes for this part. I will probably test you on this because I think it's important. All right, so the representativeness heuristic, we are going to judge the likelihood of things or objects in terms of how well they fit a prototype. So yes, in case you were kind of curious, this is sometimes where stereotyping actually comes into play. So one of the things that we know in general is that when it comes to thinking, our resources are pretty limited. So oftentimes we will engage in things like heuristics and stereotyping to kind of simplify the world around us. We like it when the world fits in neat little categories or neat little boxes. And so sometimes that means we're going to resort to stereotyping or these heuristics to help us manage the world. Now, I don't need to tell you that stereotypes can be incredibly problematic. So don't beat yourself up when you fall prey to stereotypes. Your mind wants to simplify the world. However, now that you know about these things, don't ignore instances where you are trying to simplify the world. When you meet somebody new, try not to pass too much judgment on them initially. Get to know them as an individual first. Okay, so speaking of which, we're going to talk about somebody named Steve. You don't need to write this down. Steve is meek and tidy. He has a passion for detail. He's helpful to people, but he has little real interest in people or in real world issues. So I'm asking you, is Steve more likely to be a librarian or a salesperson? So go ahead and raise your hand. Who thinks Steve is more likely to be a librarian? Who thinks he's more likely to be a salesperson? Who's like, you can't ask me to judge Dr. Gilchrist. I need more information. Yeah, a couple. Okay, but let's say I forced you to make a choice. So you have to pick one. Who says librarian? Who says salesperson? Okay, those of you that picked librarian, why did you say that Steve is more likely to be a librarian? He fits the profile, doesn't he? So you have this idea in your head of who a librarian is, somebody who's probably really introverted, probably likes books more than they like people, very detail oriented. So they probably love things like the Dewey Decimal System or the Library of Congress system. But that's the thing though. How many of you picked that Steve was more likely to be a salesperson? Why did you pick salesperson? Do you mind if I ask? Anybody have an answer? Yeah?
I mean, at the library, like the librarians are constantly having to talk to people. I mean, at mine anyway, like.
Okay.
I mean, salespeople have to talk to people too, but I mean,
Okay.
it's like the librarian has to be more interested in what the person wants than the salesperson.
Okay, somebody else? Did anybody? Yeah, why salesperson?
I think that you have to be precise on what you're marketing, what you're selling, or what the information you're giving to people.
Okay.
And also you do have to be neat and tidy as well, because you can't have people coming in a place or in an area where it looks cluttered, unclean, or like not well thought out. So I would think you would be more a salesperson. And about the people or like interest in world issues, those are job specifications that require interaction with people.
So here's what I find really interesting, regardless of what you picked. Every single one of you that gave a response and a justification tied occupation to personality traits. What if we just went off of the fact that in the world, there are more salespeople than librarians? So if we just look at the base rate of occurrence and we don't even take personality into account, Steve's more likely to be a salesperson just because there are more. So we can kind of see how we kind of tie this all together. So don't make quick, hasty judgments on people. That's today's lesson. We'll talk about this more on Monday. Have a wonderful day. Have a good weekend. Start reading chapter 8 if you haven't yet. Haven't started yet, and I will see you next time. Bye, everybody.
That reminds me of something I saw where it was asking if this lady was more likely to be a cancer.
Oh, we have more of those to come. Believe me, we have more of these